Professor John Sader describes fluid mechanics as deeply beautiful.
Understanding some of the fundamentals of how fluids move and behave, you start looking at the world a little bit differently. Once you start getting your head around it and begin to understand the subtleties involved, you can see it all around you because we live in a fluid. It's called air.
Although now a professor of applied mathematics, his PhD was in electrical engineering.
It's really interesting having both an engineering and science background. There are two different ways of viewing problems. I feel like I bring both aspects to any problem which I may encounter.
And so it was when Professor Sader was asked by experimentalists in 1992 how to measure the spring of the delicate cantilevers on atomic force microscopes, advanced instruments that reveal the molecular and atomic detail of materials and biological specimens.
What they really wanted to know was how stiff is this lever? Right? Now, you might say, oh, it's pretty easy, just push on it, you can see how stiff it is. But it's really tiny. It's about the width of a human hair.
The measurement was critical in order to calibrate the machines. Professor Sader's knowledge of fluid and solid mechanics, together with his background in engineering, enabled him to devise a practical method based on working out the maths of how cantilevers interact with air.
We started off by solving for one type of cantilever, right, back in 1999. And over the years, I worked out how to generalize it to any type of cantilevers. And there's many different types now.
The breakthrough garnered immediate interest worldwide and became known as the Sader method. Solving problems with useful solutions has become standard practice for Professor Sader.
People ask you all sorts of questions in all sorts of different areas, and you need a hook into the problem to get started. And as you get older, right, you have more experience, and then the hook gets a little bit easier.
His toolkit of techniques has been applied across areas as diverse as nanomechanics, plasmonics, rarefied gas dynamics, and even how flags flap in the breeze. Professor Sader says it's an honour becoming a Fellow of the Australian Academy of Science, especially since he's built a career out of having fun with maths, science and engineering.
I feel very fortunate in being able to just play around. It's fun for me. I mean, I don't feel like I work.